We are starting chapter 7-3, which is logarithms. Logarithms, or logs, we can call them. Really what a logarithm is, it's kind of like the inverse of an exponential function. So you guys have been doing these y equals b to the x functions. Remember, an exponential function is where the x, or the variable, is the exponent. Think about it. If I wrote the inverse of that, I would switch my x and my y to get x equals b to the y. But this is really the way we are going to write it. The log base b of x equals y. Here is a good example to just kind of always come back to. If I wrote this, 7 squared is equal to 49. The way I would write that in logarithmic form would be the log base 7 of 49 equals 2. So I'm going to write that out in quotes. This reads as the log base 7 of 49 equals 2. Now check it out. This right here is your base, right? And it's right there. This right here is your exponent. And this right here is kind of like your answer. So think about it. Watch. Again, we're going to say 7 to the second power equals 49. Okay, log base 7 of 49 equals 2. So if I asked you to do something, well, if I asked you to say 8 to the second is equal to 64, you can write that in logarithmic form as log base 8 of 64 equals 2. And again, 8 to the second equals 64. All right, we'll do more of this. Here are some important things right here, just that your b, your base, has to always be greater than 0, okay? Okay, quick graphing, okay? We're going to get into graphing later. We'll talk about it in class when we meet next. Right now, I have y is equal to 2 to the x. I have an xy chart for that. You guys are familiar with these graphs. I just plotted these points in this blue curve. But what would the inverse be of that? Well, the inverse would be log base 2 of y equals x. Okay? Just kind of like, again, in the same way as log base 7 of 49 equals 2. Okay? So if I was to graph that, really all I would do is I would switch up the x's and the y's, right? So in other words, rather than graph the point -3 1/8, I'm going to graph the point 1/8 -3. And then I'm going to graph the point 1/4 -2. And then I'm going to graph the point 1/2 -1. Then I'm going to graph the point 1 0. And then I'm going to graph the point 2 1. And the point 4 2. And last point is 8 3. So 4 5 6 7 8, and then 3. So again, all I did to graph the log function is I reverse the x and the y. All right, we're going to get into an easier way to graph logarithmic functions, okay? All right. So, again, like I said, it is the inverse. So if I wrote 2 to the y equals x, actually, 2 to the x equals y is better. 2 to the x equals y is better. I don't like that. All right, anyway. Let's try to do this. If y equals b to the x, then log base b of y equals x. Log base b of y equals x. Okay, here's what I'm trying to get to. And this one is incorrect, so let's cross this one out. This should read the log base 5 of 25 equals 2. Sorry about that. That's a mistake on my part. Let's write this in exponential form. Well, we would write 5 to the second equals 25. Everybody see that? This is your base, this is your exponent, this is your answer. That's how I think of it, okay? Now we're going to do number 2 together. 3 to the -4, in other words, base to the exponent equals 1 over 81. And is that right? Let's think about that. 3 to the -4 is really equal to 1 over 3 to the 4th. And if I wrote 3 to the 4th, if I multiplied it by itself 4 times, guess what I would get? 1 over 81. Okay? All right. You guys try these two. I want you to write these in exponential form. So pause the video and then we'll get back to it. Okay, we're back. So hopefully you got this one. 4 to the second is equal to 16. And then this one, 2 to the negative 5 is equal to 1 over 32. And again, 2 to the negative 5 really equals 1 over 2 to the positive 5. If I multiply 2 times 5 times, I get 1 over 32. So that works. Okay, now we're going to do it the other way around. We're going to write, we are given something in exponential form, and we are going to write it in logarithmic form. So again, it's going to be log, here's your base, so base 3 down here, of 81 is equal to 4. Okay, hopefully you understand that. I want you to try all these three, so pause your video. I'm giving it to you in exponential form. I want you to write it in logarithmic form. All right, pause. We'll come back. Okay, so hopefully you got this. Log base 5 of 25 is equal to 2. Log base 64 of 8 is equal to 1/2. And the last one, log base 4 of 64 is equal to 3. Okay, moving on. All right, now we're going to do something a little different. Now we're evaluating, okay? So I want you to think of it. Log base 7 of 49 is equal to 2. So think about this. If I was going to write that in exponential form, it's 7 to the second equals 49. So check this one out. This would be 16 to the y power is equal to 4. So 16 to the what power gives me 4. So you have to think about exponential, you have to think about irrational exponents. How would I get 16 turned into 4? Wouldn't it be the square root of 16? So how do I write square root as an exponent? I would write it as 16 to the 1/2. Okay? So y equals 1/2, right? And that equals 4. Okay. Try again. This one is a little trickier. So if I wrote this out, I would write 8. So first write it in exponential form. 8 to the y is equal to 16. All right, so this is a little trickier because 8 to the what power is going to give me 16. Well, here's the way you're going to do this. You're going to come up with a common base. So I can find a common base of 8 and 16, and that base would be 2. How would I write 8 with a base of 2? Well, I would write 8 as 2 to the third power, wouldn't I? But so in other words, I'm just substituting 2 to the third, but I'm taking that whole thing, which is really 8, and putting it to the y power. Just substituting in. All right, what would I write 16 as with the base of 2? Well, it's 2 to the 4th, okay? Now think about this. Doesn't it make sense that, well, first of all, let me ask you this. How do you write, when you have a power to a power, don't you multiply those exponents? You do. So you would get 2 to the 3y is equal to 2 to the 4th. All I did is multiply the 3 and the y. Now, think about this. Wouldn't it make sense that this would then equal this? Because I have the two bases that are the same. So now what I'm going to do is write 3y equals 4 and then solve for y. Divide by 3, divide by 3. So y is equal to 4/3. And that's your answer. Now, if you wanted to go back and check it, okay, with this, does 8 to the 4/3, this is me checking it, does that equal 16? Well, think about it. That would be the cube root of 8, the whole thing to the 4th power. What's that equal to? That's the cube root of 8, which is 2, and 2 to the 4th is 16, so it does work, okay? All right. Right here. Oh, I'm going to have you guys, I gave you the answers here. I'm going to cross them out really quick. I want you to try them, okay, without me giving you the answers. Sorry about that. All right, give it a shot. Try those. Pause the video. Okay, we're back. So, this first thing I'm going to do, actually what I want to do first is write these as y's, okay? You can pause it again if you didn't do that. But really what we're going to do is go 3 to the y equals 81. So what's your answer to that? 3 to the what power gives you 81? Well, 3 to the third is 27. It's actually 3 to the fourth gives you 81. All right, next one. Right as an exponential equation, it would be 9 to the y equals 27. So nothing's going to work here. Like in a whole number, because 9 to the second is 81. So we're going to do that same thing again where we come up with a common base. So a common base for 9 would be 3. I can write 9 as 3 to the second, and then I put that to the y power, because 3 to the second is 9. And then I'm going to write 27 as 3 to the third. Again, I'm going to use that, that power rule where I multiply the exponents. So it's 3 to the second to the y. I multiply 2 and y and get 3 to the 2y. Is equal to 3 to the third. And now I'm going to take this 2y and set it equal to 3 and solve. Divide by 2, y is equal to 3 over 2. Let's check our answer here, right? Let's say 9 to the 3 halves. Is that equal to 27? Well, that would be the square root of 9 to the third, and that equals, the square root of 9 is 3, 3 to the third is 27, so it does work, okay? Okay, all of this right here, I'm on the wrong video, because all of this right here coming up is what we're going to be doing tomorrow. Okay, that's it. I am done. I'm going to have you do some of the 7-3 homework, and we'll talk to you later. Bye.